Welcome to episode 2 of the podcast and what we're going to be talking about today.
Hi, Aaron. Today we're going to be talking about large language models, or LLMs, and what exactly are they, and how do they take understanding to the next level?
Okay.
And finally, why are they becoming so important in ITSM?
Okay. So shall we start by talking about what is a large language model? So in essence, the name is almost what it is. Okay. So it's a collection of language that's stored in one single place. So if you were to take all of the language in the world and you were capable of storing it somewhere, that it effectively becomes a large language model. And within AI, we refer to a language model regardless of the type of language we're storing. So when we talk about language, we often think about sentence structures. That's easy for us to understand. But from an AI perspective, if I was trying to make an autonomous car, it would be the language of driving that I would be storing. So, for example, I would take the input of the accelerator or the brake or turning or all the things that I'm looking out for on the road. That, in essence, is the language of driving. And therefore, that would go into a large language model so the AI could effectively drive the car. So that's how they work and how the data is stored.
And how does that differ from traditional AI models?
So I think there's 3 different types really of LLM, and the latter 2 sort of lend themselves into each other. So the first one is statistical model. So we basically store data inside the model, and then we use probability and statistics to work out how to respond or what the likelihood of that answer being correct is. So they were probably the earlier part of AI and how traditionally where it started. They use less compute power, so they're easier to put together. They're quite quick to respond. And most of the time, the probability is improved over time. But ultimately, it's using stats. It's using maths and statistics in order to answer a question. Where it sort of started to move forward is what we call an artificial neural network. What we mean by that is quite a fancy term, but in essence, what we're doing is just adding layers to the way that the AI responds. So rather than just using pure statistics, we might take data from 3 or 4 sources or inputs from 3 or 4 places before we make that decision. It's slightly more like the way that we would think as a human. So we don't just act on one certain piece of data. We might assess 3 or 4 things before we make a decision. And if, in essence, that's what a neural network is. And the reason they're important and the reason they've sort of allowed AI to expand is they're the sort of the fundamentals of what we call a pre-trained model. So people refer to that as GPT. So when you hear about Chat GPT, that's in essence what it is. It's a transformer model. It relies on a neural network. But the reason it's taking it to the next level is that it's using lots of different layers and lots of different methods of interpreting that data in order to both understand it and respond. And that's the way how large language models have progressed from statistical all the way through to where they are now. But it's all about adding layers, it's adding nuance, it's adding different ways of interpreting that data, and that allows them to become more and more accurate.
Okay. And how does an LLM actually learn language? And what kind of data does it train on?
So it can pretty much train on any data, and the proliferation of the internet and the cloud storage and all the data that we've got available now has allowed AI to get better and better, because the more data you give it, the better it will be. One of the things we're also doing now is to make it more specific to organizations. So rather than just having a cloud-based AI, we can allow it to learn over just your data. So it becomes much more accurate in the context of your organization or in the context of which you're trying to use it in. And the way it learns is through 3 methods, really. One is supervised learning. Okay? It's the oldest and it's still very important. So basically, you get a response back from the AI and you basically mark it as right or wrong. So a human supervises its responses. It tells it when it's got it when it's done a good answer, tells it when it's done a bad answer, and it might give it a better answer. So next time it runs, it understands how it's been taught. So no difference to how we would mark someone's homework in a classroom. The second option is called reinforced learning. This is basically, let's say, for example, we had a robot walking around a maze. Every time it hits a wall, we give it a black mark. Every time it successfully goes around a corner, we give it a tick. It's reinforcement learning. it's no different to the way that we might use reinforcement learning within the human rate, although we are trying to sort of move away from that. But basically, it's a real fundamental, you are right, you are wrong, and we're going to reinforce that in that type of way. The final way of learning is called deep learning. And this has really changed the way that AI has grown in the last few years. So similar to the way we spoke about a neural network being layers of information as opposed to being more stats-based, deep learning is the same. So what we're doing there is we are giving it more and more data. We're giving it more layers of answers. So therefore, it can start to formulate a picture of what's happening as opposed to being more yes or no. And that deep learning concept is much more like the way that we actually do learn. So we will take multiple sources and we'll combine them together, and then we'll start to form a pattern of behavior. And in essence, that's what deep learning is trying to do. You start to form a pattern of behavior. And we'll talk a little bit, I think, in the next podcast about something called prompt engineering, which is the personality of our large language model. But in essence, deep learning starts to form that personality. So that individual large language model knows how to respond for the use case it's been given. And that's effectively deep learning.
Okay. And one thing that people find really fascinating is how they generate responses. Can you break that process down for us, how that works?
Yeah, so it's still using patterns and predictive analytics, even in the most sophisticated of AI. So it's looking at the type of text you're asking it to generate or the image you're asking it to generate. And it's going back over thousands of examples of that type of text or that type of image in the past to produce something that then allows you or gives you that right piece of text or that right image structure. And you could ask it something that maybe hasn't been written before, or maybe an image that doesn't exist, but by combining pieces of text or combining previous images, it will still be able to generate something that you can use and move forward. And it's doing that by breaking that down every single time. One example, I'm going to come back to this, which are called like the kaleidoscope concept. So do you remember a kaleidoscope? It's got a certain number of colors and a certain number of patterns within it. But every time you shake it, you get a slightly different pattern forming within the kaleidoscope. And AI is really similar. So every time you ask it a question, the reason you might not necessarily get exactly the same answer, or you vary the input slightly and it gives you a different response, is because effectively it's forming a pattern. And therefore, it might give you something subtly different each time. And that's because it's still using the same types of data pool, but it's trying to give a little bit more nuance. But in essence, you're going to end up with the same colors and the same shapes, just in a subtly different order. And that's the way it works. And that's the way it's able to generate new text or new images.
Okay. And I mean, so we hear a lot about the black box problem with AI. How much do we really understand about why LLMs make certain decisions?
Yeah, I think the first important thing to note is that AI and the basis of an LLM, it lacks comprehension and reasoning. Okay, so it doesn't think how we think. It's breaking down a question structure or it's writing in a certain way based on information it has. It doesn't necessarily reason through that information. So the reason sometimes that's difficult to quantify is because it's quite difficult to see all of the data that underpins that decision-making process because it's got access to millions of pieces of information. So it's hard for us to understand how it has got to that answer. But if you break it down and think about it, it's not reasoning the answer. So it has to be within its data set. It has to know it. And effectively, it's interpreting that. It's giving us a response as an interpretive answer. So the way to think about or think beyond the black box is say, okay, what it's really doing is it's taking loads of data, it's chunking it up, it's cutting it into little pieces, and then it's responding back to us. And that's how it's giving us that generation. So it's almost like not to think of it as a black box, actually to understand that it's only ever going to be learning on the data that we provided it. And actually, some of the best LLMs are when they've only got access to the data that you need them to have access to. So their understanding is really formed around a particular subject or a particular topic, and that's when they become much more powerful.
Okay. And what do you think is next for large language models?
I think what we've got to get better at is having models trained and built by people outside of IT, and to bring in different demographics, different perspectives into the way that that training is done, and also bringing in more ideas in terms of the way the model should be responding. So at the moment, we suffer from a lot of confirmational bias within AI. So it looks at data. If you feed it enough data with the wrong answer, it will give you that wrong answer. Because back to the earlier point, it can't reason. So we have to start to allow it to have it's never going to reason, but we need to be able to bring in different opinions, different perspectives. So, a good example is if you ask an AI how it feels, it's a difficult question for it to answer because it doesn't it doesn't come with a personality. So they will respond. But what we need to get better at is thinking through the context of that question. That's quite a psychological response. It's not a statistical, mathematical response. So we need to get the models being built by people that are bringing that level of understanding. And again, we'll talk later about prompt engineering, which is starting to shift that dial a little bit. But where I think they're going to go is we need to bring in that nuance into the way that they're trained and therefore the way that they behave. And it's really important. We have to solve this confirmational bias issue because at the moment we're proliferating poor data, and that can expand really quickly, with the way that the internet and social media is based now. And we have to solve that problem. And by doing that, we've got to bring in more representation and more understanding into the LLM.
Okay. And how are they changing the way that IT service desks operate?
I think a good example is bringing in automation in solving problems. So it could break the problem down, and not only that, now it can actually start to think about how is it going to automate the solution to that. And historically, that was quite linear. So you'd have a certain issue, call a certain piece of automation. But now, with the complexity around AI, particularly as you move into agentic AI, and I know that's a more complex topic, but in essence, it's allowing it to execute multiple tasks rather than just a single task. So it will break an issue down and say, okay, I'm going to run automation A, C, and F because I understand that's how I'm going to solve that problem. And that's making such a difference within IT service management because it means that we can do so much more than we could previously with the AI, and we can solve many more complex problems with it. And that's becoming a big difference within service management, and in particular within AI operations, because we have the understanding of how to solve an operational issue, and not only that, prevent it. So things like synthetic transactions, where we can ask the AI to run the same business process for us to understand where there's weaknesses in the chain or potentially performance issues before it even happens. And that's really changing the way that we can operate within service management and really bringing down our mean time to investigate, to understand what the problem is, and also therefore our mean time to resolve, which is the critical measure. We don't want issues if we can prevent them, but when they happen, we need to solve them quickly. And it's made such a big difference to the IT service management world by being able to do that.
Finally, what's the biggest challenge in applying LLMs to ITSM, and how do we overcome it?
I think the big challenge is making it specific to the organization. At the moment, a lot of the public-facing LLMs are being trained over huge amounts of data, but it's not specific to a particular company or particular organization. So how you solve an IT problem, or even, let's say, for example, how you recruit a new person within your business, it's going to be subtly different for each individual organization. The way we're solving that problem is to make large language models more tenant-based, so trained purely on your data, or making them more enclosed so they don't have to go out to the public in order to perform natural language processing, and the model can be held internally. By doing that, you then get context-sensitive information within your organization. And I think that's going to start to make a big difference to the adoption, because from a security point of view, it's only using your data. It isn't exposing that out to the internet. So therefore, there's less security concerns about adoption of AI. And equally, the quality of the answer is going to be much higher because it's responding based on your organization and the way that you work. And therefore, it's capable of giving much better answers.
Okay. And speaking of adoption, how are some ITSMs using their own LLMs?
I think in various different ways. I mean, I think we need to allow it to do more, I think, end-to-end processing. So going back to recruitment or joiner, mover, leaver, if I have a new joiner coming in and I need a security pass and I need access to certain systems, a lot of that's going to be based on my job role. And historically, the way we've done that is to create closed personas. So when a new person starts, we probably get them 80% of the way there to the type of job they're performing. I think where AI adds value is it could be even more specific than that. So it could say, okay, and what type of activity am I going to perform on my first day? Okay, so I don't need quite so much access. I'm just going to make sure that that's provisioned for that person. Or, okay, I'm going to have a guided piece of training to get them up to speed with their job role or what they're going to try to do. But I'm going to be really targeted around the information that they need rather than having a 90-page employee handbook of which only 10% of it is relevant to me. I'm going to use AI just to give me the relevant 10%. Therefore, I can get up to speed much more quickly. It's a much better onboarding experience. I can add value more readily, breaks down some of those barriers. And that type of use case for AI is going to be really important. And there's many business processes that we can either automate and or make much more precise by just taking out the salient points. And that's one of the big strengths of AI. And it just improves that user experience.